Okay, let's unpack this. I want you to picture a scene. It's 4:45 p.m. on a Friday.
Oh, no.
The sun is shining, your friends are texting you about happy hour, and you have just finished coding a brilliant new feature for your web app. You're ready to close your laptop and go home. But wait, you can't.
You have to deploy it.
You have to deploy it.
Oh, the dreaded Friday afternoon deploy. That is the stuff of nightmares.
It really is. You're sitting there sweating, you're SSHing into a remote server, you're dragging files over via FTP, you're typing commands into a terminal, hoping you don't make a typo.
Yeah,
And then
silence.
The site goes down. 500 internal server error.
And the panic sets in.
Exactly. Why did it break?
Yeah.
Because you forgot to install one tiny library that you had on your laptop but wasn't on the production server.
The classic "it works on my machine" syndrome. It is the absolute bane of manual processes. It's time-consuming, it's prone to human error, and frankly, it's just stressful. It's no way to live.
It's a nightmare. But as we found in the stack of research and articles we're diving into today, there is a better way. A much, much better way.
A much better way.
Today, we're talking about automating that entire headache away. We are diving deep into automating web deployments with Docker, Jenkins, and Kubernetes.
This is really the holy grail of modern software development. We're moving from doing things by hand, these artisanal, handcrafted deployments, to what the industry calls CI/CD, continuous integration and continuous deployment.
And we aren't just talking about the high-level concept today. We have a specific set of sources that guide us through building a literal pipeline. We're going to mentally build this machine together.
Yeah.
It involves a trinity of tools. First, we've got Docker.
Right. Think of Docker as the packaging department. It solves the consistency problem.
Then we have Jenkins.
The automation engine, the assembly line robot. That's for building and testing, so you don't have to do it yourself.
And finally, the heavy hitter, Kubernetes.
Orchestration. That's the fleet manager. That's how we manage the deployment at scale and make sure it actually stays running.
So here is our mission for this deep dive. We are going to take a simple web app. Maybe it's Node.js, maybe Python Flask. The language doesn't matter.
Doesn't matter at all.
And we are going to trace its journey from a developer's laptop all the way to a fully running auto-scaling cluster. And the best part, no human touches it after the code is saved.
It's effectively a DevOps assessment project. I mean, if you can understand this flow, you understand the backbone of how modern internet companies like Netflix or Spotify run.
Let's start with the architecture. Before we get into the weeds of the code, give it the bird's eye view. How do these pieces fit together?
Sure. Think of it as a relay race or a shipping operation. The first runner is the developer. They write code and push it to GitHub.
That's the starting gun.
That's a starting gun.
Okay, so the code is sitting in the repository. Who picks it up?
Jenkins is like the watchdog. It's constantly monitoring that GitHub repository. As soon as it sees a new commit, it wakes up.
Yeah.
It says, okay, I have work to do. It grabs the code and it builds a Docker image.
And that image is like a sealed package of the application.
Exactly. It's an immutable artifact. Once Jenkins creates that package, it pushes it to a storage unit called Docker Hub, and that's where the handoff happens.
I see.
The final runner is the Kubernetes cluster. It pulls that image from the storage and actually runs the app so the world can see it.
Yeah, so developer to GitHub. Jenkins sees it, packages it in Docker, stores it, and then Kubernetes serves it to the customers.
Precisely. And the beauty is, because we are using these tools, we remove that "it works on my machine" problem entirely. We create a seamless loop.
Well, let's get our hands dirty. Step one in our source material is containerizing with Docker. Now, I love the idea of Docker, but the syntax can be a little intimidating if you've never written it. The source talks about a Docker file.
Think of the Docker file as a recipe card. It's just a script that tells Docker exactly how to bake the cake, or in this case, build the image.
The example we're looking at uses a Node.js app.
Yeah.
So walk us through the ingredients here. What's the first line?
It starts with the base. The file says from node.oneFree. That's telling Docker, start with a pre-built environment that already has Node.js version 14 installed. You don't have to install Node yourself, you just inherit it.
That's a nice shortcut. You aren't configuring an operating system from scratch.
Exactly. Then we set the stage with work your app. This just creates a folder inside the container where our app will live. It keeps things clean so you aren't just dumping files into the root directory.
Now the next part caught my eye. There's a very specific order of operations here. The source says we run copy_ypackage.json followed by run npm install. And then we copy the rest of the code. Why split it up?
Yeah.
Why not just copy everything and install?
This is a pro tip. It's a clever optimization called layer caching. Docker builds images in layers. If a layer hasn't changed, Docker reuses the cached version from the last build.
Okay, so how does that help us here?
Well, think about how you code. You change your source code, your actual logic, all the time. But you change your dependencies, your package.json list, very rarely.
Right. I might edit app.js 50 times a day, but I only add a new library once a week.
Exactly. So by copying the dependency list first and installing them, Docker caches that heavy install step.
Ah, yeah.
If you just change your code but not your dependencies, Docker looks at the layer and says, nothing changed here, I'll skip the install. It makes your builds go from 5 minutes to 5 seconds.
That is smart. It's efficient layering. So we've installed the dependencies, then we copy the rest of the code.
Right. Copy YL. That grabs your actual application code. Then, expose 3000 tells the container to listen on port 3000, and finally, the command to start the app.ton, cmd node app.js.
So that's the recipe. But a recipe doesn't feed you. You have to cook it. The source mentions a build command.
Yes, Docker build. You tag it with a name, something like your username @name.version. That creates the image.
Okay.
And at this point, we have solved the consistency problem. This image contains the OS, the libraries, the code, everything.
We've sealed the environment in Amber.
Exactly. If it runs on my machine, it will run on yours, and it will run on the server.
And before we send this off to the cloud, we should probably make sure it actually works, right?
Absolutely. The source emphasizes validation. You run it locally with Docker run nashp 3000.3000. That maps the container's port to your laptop's port.
So I can just go to localhost 0.3s000 in my browser.
Yep. And if you see your app, you know it works. You have successfully containerized your application. It is now portable.
Okay, so we have a container, but I'm still typing Docker build and Docker run manually.
Yeah.
That violates our lazy developer rule.
Right.
We want to be sipping coffee while this happens. Enter Jenkins.
This is where we shift from doing the work to designing the robot that does the work.
The source mentions setting up Jenkins and connecting it to Git. That seems straightforward. You give it your credentials so it can see your code, but then it talks about a Jenkins file.
Is this another recipe?
In a way, yes. This is the concept of pipeline as code. In the old days of Jenkins, you might have clicked a bunch of buttons in a UI to set up a job.
Oh, I remember that.
Add build step, add post-build action.
And then if the server crashed, you lost all that configuration.
Exactly. Or if you wanted to see who changed the build settings, you couldn't. A Jenkins file is a script you put right inside your project repository alongside your app.js that tells Jenkins what to do.
So it's version controlled.
It's version controlled, just like your app code.
So the instructions for how to build the app live with the app code itself, that makes so much sense for disaster recovery.
It does. Let's break down the stages in this Jenkins file. It's usually broken down logically. First, you have stage build. Inside that stage, the script runs the docker.build command we just talked about.
So Jenkins is doing exactly what I did manually a moment ago. Correct. And then comes stage push to Docker Hub. This is crucial. It uses a command docker.with registry.
I notice a detail there about Docker Hub credentials. That's important security-wise, isn't it? You don't want to hard-code your password in the script.
Never, ever hard-code passwords in a script that goes to GitHub. Jenkins has a secure credential store. This command tells Jenkins, hey, temporarily use these secret credentials to log in, push the image to the registry, and then log out and forget them.
Secure and automated. I like it. So Jenkins logs in, pushes the image to the warehouse Docker Hub, and now our image is available online.
And the trigger for all of this?
A simple git commit.
Right. You save your work, push to GitHub, and Jenkins sees it. It spins up, builds, and pushes. You don't lift a finger.
It's like having a personal assistant who's constantly watching your back.
Yeah.
Oh, you finished that code. I'll wrap it up and ship it for you.
But we aren't done. We have a packaged app sitting in Docker Hub. It's essentially in a storage unit. It's not running anywhere yet.
Right. It's in storage. Now we need to actually deploy it to a live environment. This is where we bring in the heavy artillery. Kubernetes.
The orchestrator. The beast.
Why do we need Kubernetes here? Why not just tell a server to run Docker run?
You could for a hobby project, but in the real world, you rarely run just one container. You run dozens, maybe hundreds. You need them to talk to each other, you need them to restart if they crash, and you need to handle traffic spikes. Kubernetes manages all of that complexity.
It manages the fleet. Now, the source describes two main configuration files for Kubernetes. The first one is the deployment YAML. And there is a key concept here called desired state.
Yes, this is the philosophical core of Kubernetes. In a traditional script, you give orders. Start server A, then start server B. It's imperative.
Like a drill sergeant.
Right. But in Kubernetes, it's declarative. You don't tell it what to do, you tell it what you want. You say, I want the world to look like this, and Kubernetes figures out how to make it happen.
And what does this look like in our example?
Well, the source highlights a specific line in the YAML replicas.
Replicas 3. So we aren't just running one copy of our app.
No, we're running 3 identical copies simultaneously.
Why 3?
Availability. If one crashes or if the server running it dies, the other 2 keep serving traffic. And because Kubernetes is constantly checking the desired state, it notices the missing one. It says, hey, I'm supposed to have 3, but I only see 2.
And it spins up a replacement.
It immediately spins up a replacement.
That is self-healing infrastructure.
It is. You could literally unplug a server in the data center, and the application would heal itself elsewhere in the cluster.
That's incredibly powerful. Okay, so the deployment YAML also uses selectors to find the app-specifically matched labels looking for app name.
Yep.
It's like putting a sticky note on the container so Kubernetes can find it later.
Exactly. And of course, it points to that image we built earlier. Your username, appname.version.
Okay, so we have 3 copies of our app running in the cluster. But they are locked inside the cluster, right? They're on a private network. How do I actually reach them from the internet?
That's where the second file comes in, the service YAML.
The service.
Think of the service as the receptionist for your building. It sits at the front desk, it opens the door to the outside world, and routes traffic to those 3 pods, those 3 offices we just created.
The source mentions type. Node port.
Right. Node port is a simple way to expose a service. It opens a specific port on the cluster's node, say port 3000, and forwards any traffic hitting that port directly to your application containers.
Now, would we use node port in a massive production app like Google Search?
Probably not. In a big cloud environment, you'd use something called a load balancer or an ingress, which gives you a real public IP address. But for learning, for this assessment project, node port is perfect.
Got it.
It proves the plumbing works.
So deployment keeps the app running. Service lets people talk to it.
Exactly.
And how do we execute this? Do we have another complex script?
It's surprisingly simple. The magic words are kubectl apply. You run kubectl apply-f deployment.yaml and kubectl apply-f service.yaml.
And boom, it's live.
It's live. You submit your wish list to the cluster, and the cluster makes it reality. You can check on it with kubectl get pods to see your 3 replicas running, and kube to get services to see the port mapping.
So let's step back. We've gone from code on a laptop to a resilient, triple redundant application running in a cluster. Now, what if I make a change? What if I change the background color of the app?
You push to get. Jenkins wakes up, builds version 2 of the image, and pushes it to the hub. Then you tell Kubernetes to update the image. And here's where it gets really interesting. 0 downtime.
Explain that, because usually when you update software, you have to restart the computer or put up a maintenance sign.
Not here. Because we have 3 replicas, Kubernetes performs a rolling update. It spins up one new version 2 container, it waits until it's healthy and running, then, and only then, it kills one version 1 container.
So it swaps them out one by one.
Exactly. It repeats that process until all 3 are version 2. From the user's perspective, the site never goes down. They might hit an old version, then hit a new version, but they never hit an error page.
That is the dream. No more 3 a.m. maintenance windows.
Exactly.
Now, we are painting a very rosy picture here. It just works. But the source material is grounded in reality. It lists some common student challenges. Things do go wrong.
Oh, they do.
What should our listeners look out for?
It's usually the small details. In the Docker stage, a common issue is missing dependencies in the Docker file. If you forget to copy Y-specific config file, or if you forget to install a library, the container builds fine, but it crashes the second you try to run it.
It works on my machine strikes back.
Anyway, it forces you to be explicit about what your app needs. Then with Jenkins, as we mentioned, the biggest headache is almost always permissions.
Right.
Credential issues. If Jenkins doesn't have the right password for Docker Hub or GitHub, the pipeline just fails. It's like trying to open a locked door without a key.
And Kubernetes. I've heard horror stories about YAML.
Oh, YAML hell is real. YAML is very, very strict about indentation. If you use a tab instead of a space, or if you indent 2 spaces instead of 4, the whole deployment fails to apply.
Seriously? Just because of a space?
Yes. The computer can't read it. It's not just messy, it's invalid. So use a linter, check your spacing, and be patient.
Good advice. And what about networking?
Port mismatches. This is a classic. Your Docker file exposes port 3000, your app listens on port 3000, but then in your Kubernetes service, you accidentally type target port. 8080.
So the service is sending traffic to port 8080, but nobody is home.
Exactly. It's like knocking on the wrong door. The lights are on, but nobody answers. Always triple-check your port numbers across the entire stack.
Okay, so check your spacing, check your ports, and check your keys. We've built the pipeline, we know where the pitfalls are, but I want to zoom out for a second. Why should our listener care? Why go through all this trouble setting up Jenkins, writing YAML, just to host a simple web app?
It's about value. If you are a student or if you're looking for a job in tech, this is a massive portfolio piece.
Because it shows more than just coding skills.
Exactly. Anyone can write a Hello World app. Anyone can follow a tutorial to make a button click. But demonstrating that you understand the full DevOps lifecycle, from source control to automation to orchestration, that sets you apart.
It shows you understand the big picture.
It shows you understand how software is actually delivered in the enterprise. You aren't just a coder, you're a systems thinker. It's practical cloud computing skill that employers are desperately looking for.
And beyond that, it's about mindset, isn't it?
It is. It's about being lazy in the best possible way. Once you start automating your workflows, you stop tolerating repetitive manual labor.
Yeah.
You become a more efficient engineer. You refuse to do things by hand that a machine could do better.
That's a great point. So to recap our journey today, we started with a manual nightmare. We containerized our app with Docker to make it portable and consistent.
We used Jenkins to automate the building and pushing of that container, creating a reliable assembly line.
And we used Kubernetes to orchestrate the deployment, ensuring our app is always up, always available, and can heal itself.
Creating a resilient, professional-grade delivery pipeline.
Automation isn't just a luxury anymore, is it?
No, it's the industry standard. If you aren't automating, you're falling behind.
That brings us to our final thought for the day. We've talked about automating a web app. But take a look at your own workflow. What are the parts of your work, or even your life, are you doing manually, over and over again, that could be orchestrated?
If you can automate a deployment, what else can you automate? Can you script your email sorting? Can you automate your data entry? If you can trust a robot to deploy your code to millions of users, you can probably trust it to handle your spreadsheets.
Something to chew on. Start small, automate one thing, and see where it takes you. Thanks for joining us on this deep dive into the world of CI/CD.
It's been a pleasure. Keep shipping.
We'll see you in the next one.